Hi, Mahmoud, as the lecturer who will be watching this video later. So before I start, let me introduce myself first. My name is Arini. I'm a physics student at my final year now. But first, I am here with my friends. His name is Francis. He's based in Jerusalem, and unlike me, he's not from a physics background. So, Francis, my lecturer actually asked me to explain my research in a simple way, so even non-physics people can understand. And tonight, I'm going to explain a bit about my research plan. So maybe, Francis, you want to introduce yourself first?
Okay, sure. Hey, Mahmoud. I'm Francis, now based in Jerusalem. I am not from a science background. Now I'm studying archaeology in Pontificia Universitas Antonianum, Faculty of Biblical Science and Archaeology. So I'm curious to hear what Arin's working on.
Okay, thank you, Francis. So, my research title is about the effect of pulse current density on the formation of nickel aluminum nitride silicon nitride composite layers using the electrodeposition method. So this project is still actually in the early stage, so I haven't collected the data yet, but I will explain the background, purpose, and what I expect to find later. So we can see in the PowerPoint a little background. Metals are used everywhere, actually in machines, tool, and pipelines also. But over time, metals can corrode, wear out, or lose their strength, especially under heat or friction. And there is one way to solve this by adding a protective coating to make them more durable. So nickel-based coatings are great because they resist corrosion and are mechanically strong. So in my research, I'm focusing on how pulse current or electrical current in short bursts can improve the quality of this coating. So this process could help produce smoother, harder, and more uniform metal surfaces. So for the research objectives here, the main objective of my research are the first one to analyze how pulse current variation affects the surface morphology using scanning electron microscopy with energy dispersive spectroscopy. This instrument helps to see the surface textures and identify which elements are present in the coating. The second one is to study the crystal structure using X-ray diffraction. The third one is to examine the elemental composition, basically checking if the nickel and the aluminum and silicon elements are successfully deposited. And the fourth one is to measure the hardness using Vickers hardness tester. So about the method, this research is experimental, and I will do it in the material physics laboratory at my university. For now, I'm still in the preparation and literature review stage. And later, I will coat a metal substrate using pulse current electrodeposition. The idea is simple actually. We coat a metal surface by using electrical pulses that control how nickel and ceramic particles attach to the surface. And the independent variable is the pulse current density. The dependent variables are the coating surface morphology, crystal structure, and hardness. Also, I will use tools like the electrodeposition setup, like scanning electron microscope, X-ray diffraction, and the Vickers hardness tester for characterization. Also, even though I don't have a real data yet, actually I already have an idea of what I expect to happen based on the previous study. When the pulse current density increases, the coating surface is expected to become smoother with finer grains or smaller crystal sizes. Actually, this makes the coating layer harder and more compact, improving its mechanical strength. And the nickel aluminum nitride silicon nitride layer should form successfully with nickel, aluminum, and silicon elements detected in the surface analysis. So yeah, maybe that's a short explanation of my research plan. Actually, I'm still working on the preparation though, and I'll start the experiment soon. Anyway, thank you, Francis, for listening. Maybe if you have any question.
Okay, thank you, Arin, for the explanation. That actually sounds so high tech. So it's like you're upgrading the metal itself instead of
Yeah,
just
yeah.
replacing it when it breaks. But what exactly do you mean by a composite layer?
Composite layer is actually instead of changing the whole metal, we just add the new layer on top. Like a composite layer means mixing two or more materials. But in my case, in my thesis, nickel and ceramics, so they can work better together.
Ah, okay, okay, I see, okay. And this pulse current thing, it's not just regular electricity, right?
Oh yeah, pulse currenting is not exactly regular. So instead of a steady current, pulse current goes on and off like really fast, kind of like blinking lights that helps coating grow smoother and more uniform, so the surface looks and performs better.
Ah, okay, that is cool. So, like, if this work, where could it actually be used?
Actually, it could be used in a lot of industries, like for example, to code cutting tools, like or maybe like a pipe plants or like engine parts. Maybe like basically anywhere you need strong materials that can resist heat and corrosion, I think.
Ah, okay, okay. That actually makes sense now. Thanks, Arint. I get the idea way better now.
Okay. Thank you, Francis. Anyway, you have any question or not?
I think no, that's all, Arint. Thank you very much.
Okay. Maybe that is a short explanation of my research plan. Actually, it's still in progress though, but also I haven't done the experiments yet, but maybe soon I will test. Maybe like next month I will test how different pulse currents change the surface and hardness of the metal. Like hopefully this study can help industry make the materials that last longer and perform better, maybe. Anyway, thank you so much, Francis, for listening, and thanks again for the question.